Today we are going to the structure, nanostructures. The structure of nanomaterials or nanostructures, how it will be there, then characterization, then technology and sizes, then related to the nanotechnology fields. So in this slide you can see this. This one I will expand this slide. In this slide you can see the first line showing the scale of nanoscale. It will be shown 0.1 micrometer to 1 nanometer. The nanoscale will be, the nano material will be up to this parameters. After that you can see this, the characterization shows the molecular, biomolecular to molecular characterization, and that what are the things we can use to view for this type of characterization. Materials are like that machines, everything and all. We can X-ray or EUV or synchronization type of equipments we can use to view the characterization of the nano materials. After that, then you can see this scanning by probe microscope also used to view the nanoscale or the nanomaterials as well as the characterization also. Inside the characters, the material characters as well as the material inside structures also we can see. Then after that, this once again we show this it shows the size of various materials as well as the nano structures. You can see this 0.1 nanometer is atom. After that, 1 nanometer is nothing but the DNA of bucketball DNA. Okay, then up to this 0.1 micrometer virus. Then beyond that it will be shows the gene, blood cells and hair sizes. So here they are clearly given the nanostructure sizes, where it is starting and where it is ending, scale, characterization, and what technology we can use to identify about these things, and sizes, comparison of sizes between the others. Next, particularly here it's showing that the size of the size and scale of this slide shows the size and the scale of the nanostructures. Here you can see this 0.2 nanometer is sizes in atoms. Beyond that, it will starting from carbon nanotubes, proteins, virus. Up to 100 nanometer we can use nanomaterials. Beyond that we are not going to take as a nanomaterial. Then transistor, most of them bacteria. Then the right side line shows the copper nanotechnology, copper material. With help of the nanotechnology, they were copper material with help of the nanotechnology at the 2001. Similarly, this is the various scale structure. Here you can see angstrom. 1 A power A dot is 10 power minus 10 meters. Nanometer means 10 power 9. Then micrometer means 10 power minus 6. Then millimeter means 10 power 9. Here indicating that the air is 50 micrometers. Okay, 50. The air length is 50 micrometer. Means diameter and a length. Okay, elongated pump that makes up the data track on CD are 50 microfarad. Minimum 0.83 micrometer long. Okay. Here similarly the length and the time. This slide is showing that length and time scale file from the point of view of material modeling. Point of view or material modeling, creating the nanomaterial with help of the various from the various scales, not with help of from the various scales. And here the scale and things is showing. These things is already we saw in the previous slides. Okay. There in the right side it shown this the things natural and the things made man-made. In the left side, in the left side it shows the things natural, and in the left side, right side of right side, things man-made they will show. Then type of material. Here materials according to the way the atoms are bound together. Materials, first of all we are going to see the material. Valence electrons are detached from atoms and spread in an electron sea that glues the ion together. The various electrons are adding, and due to the bonding they are making that, or variant atoms are bonding and making the metals strong, ductile, based on the bonding strength, relation between the two atoms. They are providing strong, ductile, conduct electricity, and heat well, or shiny if polished. These things are all providing based on the attachment between the two atoms. Then next is semiconductor. The bonding is covalence. Electrons are shared between atoms. Okay, the electrons between the two atoms, the electron is shared. This type of this providing the electrical properties depend upon the strongly on milk preparation of containments. Example: silicon, Ga, and K. Then next is ceramics. Atoms behave like a positive or negative ions and are bound by Coulomb forces. These are usually combination of metals or semiconductors with oxygen, nitrogen, or carbon. Hard brittle insulator, example: glass, procline. Next, polymers are Coulomb forces, also by weak van der Waals forces, are usually based on the carbon and the hydrogen. They decompose are moderate at temperatures are 400 to 400 degrees, and it also lightweight. So examples are plastic wrappers. Here they are showing that not based on the body. Some of the examples, the particular microstructure identifies composite materials made of different materials in intimate contact. For example, fiberglasses, concrete, wood. To achieve a specific properties, biomaterial can be any type of material that biodegradable are used, for instance, to replace human body parts. This is the drawing showing that. Okay, how do you decide a specific material for your application? Then next we are going to see what is nanocomposite.